I found an interesting website I want to share with you. I just want to go through this with you. Here, I've got a base 10 to the power of 0. 10 to the power of 0, that just gives you 1. In fact, anything to the power of 0 gives you 1. Let's take this further up. 10 to the power of 2. Or we could say 10 squared. 10 times 10, that means 10 times 10, that's 100. That's roughly the number of students in 4 different classes. Right, scale this up a bit more. 10 to the power of 3, that means 10 times 10, then times 10 again. 10 times 10 is 100, 100 times 10 is 1,000, 1,000. That's roughly the number of students in an average size secondary school, 1,000. So after 1,000, we start talking in millions. What is 1 million? Right, to give you an idea of what 1 million is, imagine there are 1,000 secondary schools, and you want to know how many students there are altogether in those 1,000 secondary schools. Right, you'd get 1 million. So roughly 1 million students, if you were to count all the students in those secondary schools. Right, so 1,000 secondary schools, you'd have 1 million students. So after 1 million, we start talking about billions. Right, so what is a billion? What is 1 billion? Well, 1 billion is 1,000 lots of millions. So we're talking about 1,000 lots of millions. Then after 1 billion, you talk about trillions. Right? But what is 1 trillion? Well, 1 trillion, following the same pattern again, 1 trillion is 1,000 lots of billions. So you imagine a billion, then a billion, 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 billion. If you keep saying that 1,000 times, that's when you get 1 trillion. And then you've got 1 quadrillion. So after a trillion, you start talking in terms of quadrillions. 1,000 lots of trillions make up 1 quadrillion. And then you got, after that, you got 1 quintillion. That's 1,000 lots of quadrillions make up 1 quintillion. Now I'm going to stop there for a moment and give you an idea of what 1 quintillion is. Right, imagine you got a grain of sand, an average size grain of sand in your hand. Now if you put a grain of sand in your hand, it's hard to see unless you look very close. You'll be able to see it. But that grain of sand contains 43 quintillion atoms. I repeat, roughly 43 quintillion atoms in that one tiny grain of sand. So obviously atoms are very, very, very small. Now scale things up a bit. Well, you know what a grain of sand is. It's very tiny. Let's think about a human being. Right? An average size human being is obviously a lot bigger than a grain of sand. So roughly how many atoms make up you and me, right? An average size human being. So we have to look further down the website. Here we have it. An average size human being has got roughly 7 octillion atoms. 7 octillion atoms. Right? Obviously it's going to be a lot more atoms. Remember, a grain of sand contained a lot of atoms. So obviously a human being is going to have a lot more, right? And then if you start thinking about, well, you got a human being, but then Earth, the Earth is obviously a lot bigger than the human being. And then the sun, right? As remember, a sun is a type of star, it is a star. The sun, our sun, is a lot bigger than the Earth. So if you want to consider the number of atoms in our sun, we have to go further down. Right, here it is. Our sun, right, the nearest star to us, contains roughly 1 octodecillion number of atoms. That's 10 to the power of 57. Remember, once again, that does not mean 10 times 57. I'm talking about 10 to the power of 57 number of atoms in our star. And it's just an average star. Our star, the sun, is just an average star. Obviously, there are some stars smaller than our sun and some stars a lot bigger. Now, scientists estimate there are 10 to the power of 23. I repeat, 10 to the power of 23 number of stars in the known universe. In fact, there are more stars in our known universe. There are a lot more stars, like our sun, in the known universe than there are number of grains of sand on this earth. Right? If you were to count the number of grains of sand on earth, there are still many more number of stars in the known universe. Okay, so 10 to the power of 23 stars in the universe. Now, what if I was to ask you, well, how many atoms are there in all those stars that I've just mentioned? Right? Not just one sun, not just one star. I'm talking about 10 to the power of 23 number of stars. How many atoms there are in all those stars? Well, if you just take the average star, like our sun, it's got 10 to the power of 57 atoms, multiplied by 10 to the power of 23, that's the number of stars in the universe. That'll give you 10 to the power of 80, which is further down. There you go, 10 to the power of 80. Number of atoms in all the stars, in all the galaxies in our known universe. Right? It's just an estimate. But it doesn't end here. The numbers don't end here. In our website, in this website that I found, I've just said to you there are 10 to the power of 80 number of atoms in all the stars, in all the galaxies in our known universe. Right? But I can go further down. Right? I've barely scratched the surface of this website. I can go further down. Obviously, you can see some of these names are getting hard to pronounce. Right, I'm going to go all the way down. Right, I'm just halfway there. Right, go all the way to the bottom. There you go. Right, 10 to the power of 10,000. That's obviously a huge number and it's got a name for it. Okay, I'm not going to try to pronounce his name. It's difficult to pronounce. But what I'm trying to say to you now is, okay, you will have heard of the word infinity, infinite. Now, infinity is infinitely bigger than this number that I've got here.